Welcome. Today we're going to talk about angles, degrees, and special right triangles. We're going to talk about the first part of this, which has to do with angles and Pythagorean Theorem. Okay? We're going to use some quadratics, which is a little bit of Algebra 1, Algebra 2, and we're going to solve some problems. So let's look at these. The first thing we need to talk about is angles. And of course, we remember how to name angles because this would be angle BOA or angle AOB. One of the distinctions that we're going to make in this section is I'm going to say we can tell you which way it's opening up. So this arrow says it opened up. And a lot of times in trigonometry we're going to label this theta. So we're going to call it or angle theta. Alright? Theta is just like x or anything else that is unknown. Theta is just what we use to denote that it's an angle. Alright? So when we talk about it like this and we've designated a way that it opens, we now have a terminal side and an initial side. The terminal side is where it stops. So the terminal side is OA and the initial side is where it starts, so where that arrow starts before it goes up. So the initial side is going to be ray OB. So that's kind of how this works. That's how we talk about angles in general. Positive or negative angle. If you think about an airplane, if it's going at a positive angle, the relative term is always going to be directly in line with whatever it is that is doing the positive or negative angle. And there's two choices. It could go up or it could go down. So if it's going up into altitude, this is going to be a positive angle. And if it's going down, this is going to be negative. Now notice, positive or negative is calculated in relationship to level. So in this case, straight out from that airplane is level. So if it continued on its current course, it wouldn't have a positive or negative angle. But if it was going up, it'd be positive, and down would be negative. All right? That's basically the gist of it. Two things you've heard of before: complement, supplement. If you compliment somebody, you're saying something complimentary to them. Complementary, with an E, is describing two angles that add up to 90 degrees. So for example, 60 degrees and 30 degrees would be complementary angles. Supplementary angles add up to 180. So for example, that would be like 120 and 60. The way I like to think about this is complementary and supplementary. If you in general look at it, this kind of forms with the C, it forms like a 9, 0 almost, and the supplementary forms an 8, like a 1, 80 maybe. So the S kind of looks like an 8. That's kind of how I used to remember it. All right? And so that's complementary and supplementary. Here's something to think about. And that's all I'll say about that. Finding the ments. Let's find the complement and the supplement to each angle. Well, you know how to add and subtract. And so if I'm going to find the complement, it's going to be what adds up to 90. So obviously the complement of 40 would be 50. And the supplement adds up to 180. So this is going to be 140 because 50 plus 40 is 90. And then 140 plus 40 would be 180. A little bit trickier here with the 110 because the complement is going to be what adds up with it to get 90. Well, in this case, we're going to have a negative angle, but as we discussed a couple slides ago, you can have a negative angle. That's okay. And the supplement is going to be 70 degrees. So in general, let's find a general rule for this. If the angle is theta degrees, meaning we don't know what it is, well, what if theta was 5? The complement would be 90 minus 5, or 85. If theta was 10, it'd be 90 minus 10, or 80. So in general, the complement is going to be 90 minus theta. Okay, if you don't know that that works, look at it. Okay, Complement is 90 minus theta. So 90 minus 110 is negative 20. 90 minus 40 would be 50. So the supplement then must be 180 minus theta. All right? And if you need to check that, just look back at these two examples. 180 minus 40 would be 140. That gives us the supplement. 180 minus 110 would give me 70. All right, so that's an in general kind of a thing. Special triangles. We've talked about this before. Special triangles are right triangles. They have one right angle here. All right? They have a hypotenuse. That's the side opposite the right angle. They have two sides called legs. One here and one here. And they have two acute angles, and we know that the angles must be acute because the total of the triangle is 180. So if there's already 90 taken up, to divide that 90 that's left into two angles would have to be, less than 90. That's an in general kind of a thing. Using the Pythagorean theorem. Here is an in general kind of thing. In general, I'm going to label the 90-degree angle C, and the other two angles are going to be B and A, as an in general kind of a rule. Opposite of this side is going to be the small lowercase letter, and I'm going to have to really exaggerate it here for the C because they look the same. And so opposite of C is little c, opposite of B is little b, opposite of A is little a. And when I say little, I mean lowercase. And if I put in some values for these, let's say 13, x plus 7, and x, we can use the Pythagorean theorem. This is a little bit more complicated than ones you've maybe done before. Using the Pythagorean theorem, well, we need to know what the Pythagorean theorem is. The Pythagorean theorem says a squared plus b squared is equal to c squared, where this is a leg, this is a leg, and this is a hypotenuse. Okay? Let's set up the equation and see what it looks like. A squared, which is going to be x squared, plus x plus 7 squared equals 13 squared. Well, let's look at that for a minute. Is this possible? Yeah, it's definitely possible. It's a little bit more complicated than just having numbers, but let's look at what happens when we try it. We have x squared, and then this is going to be a little foiling action here, right? Do you remember how to FOIL? Okay, let's look down here. X plus 7 squared is really x plus 7 times x plus 7. So we'll have x squared, x times x would be x squared, x times 7 would be plus 7x, inside plus 7x, last plus 49. All right, and so we're going to have plus x squared plus 14x plus 49 equals 13 squared, which is 169. You might not have stayed with me on that one. This might be a good spot to rewind because then you can see what I did there. I FOILed that middle term, that x plus 7 squared, and got this down here. Well, obviously, this is getting messy in a hurry. So let's see if we can, combine like terms. Let's look at what we get. This gives me 2x squared plus 14x plus 49 equals 169. Well, luckily, I can combine some more like terms, right? Because when I've got that 169 and that 49, this is good stuff, right? Well, the problem is this. What do I want? Now, I'm going to want to solve for x, I know that, but if I move it to the right side, I'm going to end up with numbers over here, an x squared and an x. Let's try to use something different. I'm going to try a little something here. Let's see if we can copy this. And I'm going to paste. Ooh, it worked. Good. And let's see if we can solve this. I'm going to use a quadratic. And I remember the quadratic formula to be x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, that means the key is going to be must solve for 0 first. So I have to have a 0 on one side. So I'm going to subtract 169 right away from both sides. And when I do that, I get 2x squared plus 14x minus 120 equals 0. Now I can use the quadratic formula. This is going to be a, this is going to be b, this is going to be c. So x is equal to negative 14 plus or minus the square root of 14 squared minus 4 times 2 times negative 120 all over 2 times 2. When I simplify this, what do I end up with? Negative 14 plus or minus the square root of. Now 14 squared. If you don't know what 14 squared is, this would be a good time for one of these handy dandy guys here. Got to find one with batteries. 14 squared, 196 minus, and this is going to be 8 times 120 plus 960, because I'll be subtracting a negative, so I'll have that over 4. So I've got negative 14 plus or minus the square root of 1156 over 4. And this can go one of two ways. Alright, so I've got negative 14 plus square root of 156, well, or 1156. Let's do square root of 1156. That's going to be 34. And I've got negative 14 minus 34 over 4. Well, this way, it gives me 20 over 4 equals 5. This way, it gives me negative 48 over 4 equals negative 12. Well, remember what I'm actually looking at. I'm looking at this distance here, this length. Well, if x is negative 12, that means that this is going to be negative 5. Well, I can't have a negative value, so it's not going to be this one. So x is equal to 5 is my answer. And if I go back over here, I end up with b is equal to 12 and a is equal to 5. That's the basic gist of this, guys. I hope you were watching and you rewound if you needed to. Please write some notes in the margin if you need to. Come to class tomorrow having watched it and doing that summary. All right, we'll see you guys next time.